All right, now that you guys have had a chance to take a look at your homework, let's talk about the warm-up. I'm gonna, remember, each time go through, make sure you show every step. You guys can be doing these in your notebook, and then we'll go over them in just a few moments. So pause the video and have them do this, and then when everyone's roughly finished, we can go over the answers in about 3 minutes. All right, so let's take a look at how we work these out again one more time. So this should be review from what we guys did for homework. So we have a $120 jacket. And then from there, we decided that, okay, there are two ways to do it. We could either multiply it by the discount and then subtract the discount from the total cost, or we could multiply, so we could do something like this, times 0.3, figure out the discount is $36. Fix that. Figure out the discount was $36. And then do 120 minus 36, which says, okay, it's $84. Or we could do it the other way, which would be to subtract the discount from 100. So we multiply it by 0.7, and then we go straight to the $84. Either way, we get the same answer. Okay, so just a reminder how we did it. So if we have a 10% discount on this next one, that means we're really going, so we come over here and go 1,500 times 9/10. So let me go ahead and do that on my calculator. Helps if you turn your calculator on first. I get the cost of this new car being $9,450. Okay. If we have a sweater, we have an 18% discount, 3% tax. We said earlier that would be like multiplying 35 times 0.85. 35 times 0.85 gives us $29.75. Okay. 29. All right, so then the same thing here. So an employee at a restaurant receives a 60% discount on meals. If the total they pay before the discount is $32.20, how much do they pay? So we know that they're going to multiply $32.50, sorry, not $32.20, and they're going to pay 40% of their meal costs. So we're going to multiply $32.50 times 0.4. This person's meal ends up being $13. Not a bad discount on your meal. A shirt is advertised as buy one, get one 50% off. So the original price of the shirt is $12.98. And you take it to take advantage of every shirt is $12.98. So take advantage of what would be the price you would pay per shirt. So if I buy one and get one 50% off, I'm going to buy the total. So I'm going to pay $12.98 for the first shirt. And then I do $12.98 times 0.5. I'd pay $6.49 total for two shirts. So that's my total I'm going to pay now. So plus $12.98. So I paid $19.47 for both shirts. Now I want to know how much I pay per shirt, so I'm going to divide that number by 2. So I can see, okay, per shirt I pay $9.74. Here's my final answer. Now it says $9.73 and 5/10, but we all know that we round up. If hotel costs $155 per night, you get a total 30% discount. That's a great discount on a hotel room. But then you pay 5.5 sales tax. You're actually going to pay $155 times that 70 times 76, or 0.76. 5. That's not right. 745. Man, it'd be great if I never made mistakes, but then I wouldn't be a person. 745. So 155 times 0.745. We get $115.48. And again, we round up 115. 47.5 is what we really get, so we'd round to 48. Hotels and all businesses are always trying to make more money. All right, let's move on to today's lesson. Today's lesson is simple interest. Okay, so I can use the simple interest formula to find the interest earned on a savings account, or find how much interest I owe on loans or credit cards. Now, it's a little more complicated than this once we get out into the real world, but this is our good starting point. We're setting up the idea of simple interest. Eventually, we get to talk about something in your later classes called compound interest, where they take what you owe and they add it to that every single time. Simple interest is just exactly what it sounds like. How much would I make over a certain period of time? And to use that, here's the equation we use. And this is exactly what simple interest is. It's a product of the principal, the annual interest rate, and the time expressed in years. So we always do our time expressed in years. This is a key to the point. So I want you guys to take a second and highlight that in your notes. It's always expressed in years. It's not going to be by month. You might have a decimal point for years. You might have a whole number. Might have a fraction. If it's 18 months, you could do 3/2. You got lots of different ways to think about it, but it's expressed in years. Okay. So interest times principal times rate times time. Okay. So let's take a second before we go too much further. Let's talk about what those are. So I'm going to have you in just a few moments. I want you guys to work for about 3 minutes and define these 3 words on your table. Work with your group. If you're on one of the sides, work with a pair of 4s. Work with the table that's directly next to you. That's on the same either horizontal or vertical section for you. If there's only 3 of you, that's fine too. 3 minutes. Define those words, and you guys can restart the video once you've done that. All right, so let's start. We'll start with interest. Interest actually kind of has 2 meanings. Hopefully you guys got them. Interest is the fee paid for borrowing money from a person or institution. Now this could work both ways. You could pay that your institution could pay you. Say you're putting your money in a bank, and they're paying you interest to use it because they'll loan it back out to other people. They'll give it to who want to buy cars or use it for houses, things like that. So the money you have in the bank doesn't just sit in the bank. It's there, but it probably is being used by other people at the same time. So they'll pay you an interest. And then if you use their money, like you're buying a car and you take a mortgage, or not a car, or you're buying a house and take a mortgage, or you buy a car and you need to borrow money to do so, you will pay them a fee for using it. So it could either be positive to you, or it could be negative. You have to pay more than what you borrowed. The next thing is the principal, and this one's a little easier. This is the amount of money you've either borrowed or saved. So this is what you're going to multiply your interest times. Okay, so it could be like, hey, I'm saving. I need to buy a car, and I'm borrowing $15,000. Or if I've saved $50,000, and I'm letting that accrue so I can have it for my retirement account. Next one is rate. In this case, we're talking specifically about interest rate, so it's a percent earned over a specific period of time. Now, rate has a larger definition, but right now we're going to use it as a kind of an interest rate kind of thought. So it's the percent of it earned or charged over a specific period of time. I'll leave these up for a second. You guys can pause the video if you need to copy this down. Put it underneath where it says principal rate time in that pink box. So you have this just so we know the vocabulary we're talking about. All right, so everyone's gotten the vocabulary written down. Let's take a look at this first problem. Arnold puts $580 into a savings account, and the account pays 3% simple interest. How much interest will he earn over each rate of time? So we've got a couple pieces we have to get. Now, our original formula is interest, or your simple interest, equals the principal times the rate times the time. So we need to be able to pull all that information in. So let's go through and highlight that information on paper. So we have $580 as my principal. So we'll put that in pink. We'll switch to blue for my interest rate. Okay, so there's my rate. And then finally, we'll go over here to this bright yellow for time. And again, it's in years. So we're going to just take a minute and use our substitution property and plug it in. So interest equals the principal of $580. Okay, times this interest rate, which we're going to turn to a decimal, 0.03, times 5. Okay, so take out your calculator and figure that out. And you can put the upside about it, you can put it all in one step. And you can go 580 times 0.03 times 5. And you'll find that the interest that he's going to make, that Arnold's going to make, is a total of $87. So over those 3 years, that's $87 in free money that you get that you wouldn't have earned. You didn't do anything to earn. You just put your money there and let it sit. Now, there are other ways that we can do bigger interest, but this is a good start for us. So now at the end of these 3 years, if he didn't take any money out or add anything to it, he's got $667 in his bank account. All right, now it's your turn to try. Try with Jose's savings account. Go ahead and pause the video and see what you come up with. All right, so let's talk about how we set it up. Same problem we had before. We're gonna set up the same idea. Let's take a look. So we've got interest equals principal times rate times time. So again, I think we had this purple will make this be our, yellow was our time. So we'll go ahead and do that. We did this blue, I believe, for our rate. So our rate is 3.25%. And then I think it was this purple for our principal. So let's plug that information in. Interest, oh, I got a purple pen now too, is $1,200 for the principal times the decimal equivalent of 3.25%. There we go. Helps if I can write it correctly. Times the amount of time you have. You can either do it with dots or do the percentage. I find dots a little harder just because I have a decimal point, so I like to use mine with percent with these. So let me type that in my calculator, see what I came up with, and see if you guys agree with me. All right, so I found that his simple interest rate, that he's actually going to make more money than she did, but it makes sense. He put almost twice the amount in. His simple interest, it's even a little higher. He's going to make $117 over that 3 years. So he'll end up with $1,317 at the end of this 3-year period for him. Okay? And that's better because the last person, it was even a longer time frame. All right, let's take a look at a slightly different problem. So what about this idea? So now we have the big trick on this. Well, look, goes Mr. Maloney. It's the same basic problem as the first one. It is very, very close. You're right. You're right. When I said, this information is the same, we've got our simple interest being the same, but what we don't have, we have our time being different. And I'm trying to catch you. I'm trying to trick you. So one of the things we remember to talk about was time was always measured in years. I'm trying to catch you. I really was. So now when we do our problem, interest equals that $580 still, times our decimal equivalent, 0.03. But this time, instead of making it times 6, we're going to express this in years. So we're actually going to say it's times 0.5. Okay? He's only going to have 6 months. So when I put it into my calculator, it's 580 times that 0.03 times 0.5. We're going to find that he makes $8.70. Make sure I typed everything in right. I did. All right. So we're going to find out that his simple interest is $8.70 for that time period, because he only made for a half a year, and we have to remember that interest is always expressed in time, is in years. Okay. So we had to change it. All right. Your turn. Pause the video and see what you guys come up with. All right. All right, so let's see what we come up with. I'm doing it right now on my calculator. The key to this problem, though, is right here. So if our interest is here, our principal is still that $1,200 times our interest rate of 0.0325. This time, our decimal is going to be just 3/4, or you could use fractional or the decimal. It's up to you. And when I put that into my calculator, 1,200 times 0.0325 times 0.75. I'm just making sure I typed everything in correctly. That my interest would have been $29.25. So he earned an extra almost $30 over that 9 months. That's not bad for a quick, not working too much and just letting it sit there. Now we have our second situation. Our second situation is more of a very common thing. Instead of putting money in the bank, you're borrowing money from them. And you typically pay a higher interest rate. It's based on the rate going with the Federal Reserve. And if you're watching the news, you'd see all this. There's a lot of information about that. But so Rondell's parents, it's the same formula though. It's still interest equals principal, rate, and time. So here's my principal, here's my rate, and here's my time. So how much interest would his parents pay over that life of this loan? So what's the cost? In this case, it's the cost of borrowing the car, cost of buying the car, or the cost of the loan, because banks aren't just going to give you money for nothing. Okay, so principal is $6,300 times 0.06. And since this is in years, we're just going to use 2. So 6,300 times 0.06 times 2 years, we find that how much simple interest is he going to pay? Well, the interest is going to cost him, or cost Rondell's parents, $756 to go ahead and to actually get this loan. And that's not a bad amount of money. They're going to pay just over $7,000 for the car. That's not a bad interest rate. All right, it's your turn to find out if you can figure out how Phoebe works. Go ahead and pause the video and see what you come up with. All right, so let's take a look at how Phoebe's worked. So again, we have all of our information. I'm just going to highlight in one color this time. $2,600 for our principal, 8% for our interest, and 5 years for our time. So we're going to plug that into our formula. Interest equals 2,000 times the principal times our rate, 0.08. 8's not very good. Times 5. So we're going to find out roughly what this is going to be. So when I typed it in my calculator, I get that the interest is going to cost her to repay that loan for her college tuition. The simple interest alone is going to be $1,040. It's going to cost her almost half as much as it cost her to go to this to take that loan out. A couple of ways you could fix this as you get older: look for a lower interest rate, pay your loan back at a faster rate, so the shorter amount of years. So if this was down to 2, you'd be much less when it comes to how much money you pay off. It's the same with what we're going to talk about in just a second with credit cards. So Derek's dad bought brand new tires, $900 using his credit card. The interest rate on the credit card is 19%, and that's actually right now very, very low. Right now, I think the rate is around 28% for most people. He has no other charges. If he does not make a payment, how much is he going to owe at the end of 1 month? How much money will he owe at the end of 1 month? So this one takes a little bit more into the problem. Okay, so we're still going to start out with our simple interest formula. Principal times the rate times the time. So our principal is $900. Our rate this time is going to be 0.19, but then this part gets to be a little trickier. I'd use 1/12. I prefer the fractions if I have a choice. So, and that's what I'm going to put into my calculator too. I'm just going to do 1 divided by 12 and use that as my number. That decimal equivalent, if you'd rather use that, is 0.083. We'll round to the nearest hundredth, okay, or thousandths in this case. So if I type that into my calculator, 900 times 0.19 times 0.083, he's got $900. So his simple interest alone, okay, let's go back over here, sorry. His simple interest is going to be another $14.20. Now it says 19.3 on your calculator, but again, we talked about this the other day as we round up businesses or jobs to make money. So now how much will he owe after 1 month? Well, that means that we're not quite done yet. This is just the interest. What else does he owe? He owes the original. So it's going to be $900 plus that $14.20. So he's going to owe $914.20. And that would keep going up and up as the years go on. All right, it's your turn to give it a try. Pause the video and see what you come up with. All right, so Mariano paid for a plane ticket that cost $325 using his credit card. His interest rate was 13.5%. That's really low. And no other charges on his credit card, but he does not pay off the balance at the end of the month. How much money will he owe after the month? So again, come back to our interest formula. Principal is $365 times our interest rate times, and it's the same number we used before, so 0.083. And that's 1/12 as a fraction or as a decimal. Type that in. This person's going to owe, so in addition to that, his interest on just 1 month is going to be $4.09. Not a lot, but still going to end up paying more. So after 1 month, he's going to owe $369.09. If he doesn't keep paying, that interest keeps getting bigger and bigger from each time frame on. That's what we'll talk, and the difference between compounding. So if I add it and then I do a new interest, that's what's the difference between simple interest and compounding. If I add it up every time frame, then I get it a little bit faster and the interest grows faster. All right, last problem we're going to look at. Okay, so Luis is taking out a car loan for $5,000. He plans to pay off the car loan in 2 years. At the end of the 2 years, Luis will pay $300 in interest. What was the interest rate? So now this goes into thinking of our problem. What do we know? I have an interest, I have my simple interest, I have my years, and I have my principal. What I'm missing is exactly what it's asking for, the simple interest rate. So let's think about it. If it's interest equals principal times rate times time. So I'm coming over here and I know my interest is 300. I know my principal is 5,000. I don't know my rate, so I'm just going to leave R in there. And I know my thing is time. So what I'm going to do is I'm going to combine my like terms. So I'm going to mark these out. I'm going to multiply these two together because I can. And go, okay, so 300 is equal to 10,000 times the rate. Now, we talked about this. We've done this a lot. How do we solve when there's something here? If it's multiplied, we use its inverse. So we do 300 divided by 10,000. And we get that. We come over here and we divide both sides by 10,000. So we get his rate being 0.03, or the correct interest rate is 3%. Pretty good car loan. All right, your turn to figure out this last one. Go ahead and pause the video and see what you guys come up with. All right, so let's see what we came up with. So we know, let's see what we know. Callie borrowed $40,500 from the bank to pay part of her tuition. She will repay the loan by paying $120 a month for the next 4 years. What was the simple interest rate? So we know for 1 month, this is a little bit trickier. I like that you guys were seeing this. Interest is $120 per month, right? We know that much because that's what it says right here. And we know that's her loan payment. Okay? So we know her principal was $4,500. And we know we don't know her rate. That's what we're asking for. And then finally, we know that she paid for 4 years. Okay? So we can figure out this last little bit. So we've got a little bit more math to do. So if we know we paid $120 a month times a month for 4 years, that's times 48. So we're going to come over here and go 120 times 48. She paid a total of $5,760. Okay? So the difference between the two, this one's a tricky one. So we'd subtract it, we get $1,360. I'm sorry, $260. Helps if I can do my math correctly. So that becomes our new number over here. Instead of plugging in 120, we're going to put $1,260. And then we have our time over here as being 4. So we take 4,500 times 4. So we get 1,260 is equal to 18,000 equals the rate. Divide both sides by that same 18,000. So we take 1,260 divided by 1,800,000, and we find that her interest rate was 0.07, or better yet, 7%. All right. So last thing I want you guys to do, I want you to work these problems in your notebook, in your binder, and your notes, and then I want you to respond to this on MyGAC. This one is due before we come to class on Thursday when I see you guys again. Make sure you explain to me when you're reading a couple of sentences, 1 or 2. Why would you choose that over? Or just don't tell me that's the math. Tell me why would it make more sense to do it one way. And there is no right answer. One will pay a higher rate than the other, but you have to think about, what about my money being tied up for 5 years or 4 years? Which one's better? So make sure you kind of keep those in mind. When you finish that, you can start your homework. You guys have a great day. I will see you on Thursday.